Alrighty, Algebra 2, let's get into this problem right here. So, what if we're given an equation that's written in standard form, like the one we have here, and not written in factored form? It's not immediately obvious what our zeros are going to be, and it's not immediately obvious what our zeros are going to be, but we can figure that out if we factor our equation. So to factor, we want to look at these three terms and decide what can I factor or divide out of all three of those. And I see that all three of these are divisible by a 4x because a 4 goes into the coefficient of each term, and each term does have at least one x for me to divide. So I'm going to divide all of these by 4x. So when I go to rewrite my equation, the thing that I'm dividing by is going to go on the outside right here, 4x. And then on the inside of my parentheses, I'm going to write what I'm left with after I do that division. So 4x to the third divided by 4x, I'm going to be left with x squared. 4x squared divided by 4x, I'm going to be left with just an x. And then negative 24x divided by 4x, I'm going to be left with just a negative 6. So now that I've got this, I'm left with a quadratic inside my parentheses. I can factor my quadratic. Remember, to factor, I'm looking for a pair of numbers that satisfy two conditions. The first condition is that they have to multiply to negative 6. The second condition is that they have to add to 1 because the term or the coefficient in front of that x is 1. So when I think of the list of numbers that multiply to negative 6, I can think of 1 and negative 6. And then I can reverse the negative sign here as well. And then I've also got 2 and negative 3, and then negative 2 and positive 3. Okay, so when I go through that list of numbers, the only pair that also adds to positive 1 is going to be this last pair right here. So I'm going to factor my quadratic inside the parentheses in there. So I have f of x equals 4x. And then when I factor this part here, I end up with x minus 2 and x plus 3. So when I end up with that, now it becomes a little more clear what my zeros are going to be. So this first zero, I'm going to have at just 0. The second 0 is going to be at positive 2. My third 0 is going to be at negative 3. So I can go ahead and plot that. So here is 0. I've got 1 at 2. And I've got 1 at negative 3. Okay, the other thing I want to do is figure out what my y-intercept is just so that I've got another point. And I'm going to go ahead and plug 0 into my original standard form equation. So when I do that, I can see that all of these terms here do end up reducing to 0. So my y-intercept, I should have replaced this 0. I should have replaced that x with a 0 there. So my y-intercept is still at 0 here. Okay, cool. So now that I know that, now that I know my zeros and my y-intercept, I can go ahead and just graph a quick sketch. So I see that my degree is 3, and my leading coefficient, I'm going to shorthand that with an LC. My leading coefficient is 4, so that means my graph is going to have the end behavior of the right end pointing up and the left end pointing down. So it's going to look a little like this. And I have my sketch here. So as always, I want to quickly just check this on Desmos or on my graphing calculator and just see what that looks like. And when I look at Desmos, that looks pretty close to what I have on my sketch. So I don't really need to change anything here. This is a pretty good sketch for the information that I have. All right, nice job. In the next couple of examples, we'll go through writing an equation given a graph and writing an equation given a table.